Christmas present, so.
Surprise. We also got a review.
We have our staff set up overtime by the we have our 40 people. We weren't like yeah, I mean, it's like it got so technically sold out. Percent of our accounts, we're gonna. We want to have the application actually do something. Because right now all they'll say, "Hi, welcome to marketing," and that's it. It's so sad. And again, I feel like.
Oh, it's easy. So good.
Yeah. Like tons of
Yeah, it's hilarious. But it, you know, actually sort of reminds me of that kind of. Except not testing.
Oh yeah, and I want to about the Grammys. Because everyone's like, hey, there's a form and everything, but it's so cool. And like everyone doesn't know one back. It's got like, you know, that one is another one to take. He did and he's been out like for 2 years. So it's more like a makeup board than anything else.
You have to save it.
But everyone's like,
you have to
oh
save
no,
it.
they're
Like, you have to do that.
Beyonce. Even though, you know, back when I wanted to use the entire album.
Well, I mean,
why didn't it save the extension? And I'm scared that if I change one thing, a lot of things are gonna fall.
I tried to keep on getting my cards and shake them like that.
For like that file, when there's a file, yeah, you're just supposed to, like, it will work. Just save it as a write extension and then replace it. Yeah. And then it'll work again. That took me like 15 minutes to be like,
Let's start. Just because I heard somebody saying, let's ask a question. So my first thing was going to be, how did it go with the homework? Anybody mystified by something? Want to bring up some general questions before we go into detail about Rails or anything else? Yes.
Well, I was working on the chapter 5 and 6 of the book, and going with the whole the depot application on my own, and what I realized that maybe people who are on Mac have the same problem as me, or maybe it might be a different version of Rails or Ruby, whatever it is. So there's in style sheets there's a file called something.css.scss.
Right.
When I did the scaffold, it automatically created the file. But it's not called the extension is not SCSS. It's only SCSS.
Okay.
Is that a problem?
Let me explain a few things. Very good point. So, because it does touch on a few things. First of all, the general point is that the platforms we are using are pretty much cutting edge, and so they change fairly often. Although Rails is pretty stable and Ruby is pretty stable, you'll find some things which maybe don't match the book exactly, or maybe something newer has come along. Second thing about Rails, and this is a convention you will see elsewhere. When you see a file with 2 extensions like that, generally what that tells you is that there's a pre-processing step that's happening automatically that's converting the SCSS file into a CSS file. Okay? So it's just illustrating or driving that point home. If you see a file that's simply SCSS by itself, it means that, well, it depends what the file is, but I wouldn't necessarily worry about it because it could be that piece of the subsystem or whatever you're looking at didn't follow that convention. So basically SCSS, and I don't use SCSS myself, you'll see a lot of tools in the Rails world or in the programming world where some developer decided that it's just too much of a hassle to type in all those angle brackets. I want a way to not type angle brackets. And so they come up with a new tool which converts the thing without angle brackets into the thing with angle brackets. Or in the case of SCSS, there's a lot of repetition. So, and that's an understandable impulse. The problem that arises, the reason I personally don't use it, although plenty of people use it, is that you end up with having to learn a whole bunch of different languages, which are all a little bit different, and the payoff, unless you're writing, unless your job 24/7 is to write Rails applications for clients, the productivity benefit is negligible compared to the effort of learning it, and also the dependency you now have on just one more tool that can malfunction. So that's what that story is about, basically. Did somebody say that you can just ignore it? Did I hear somebody mumble, ignore it? No, I thought I heard it. You said that, yeah. Just ignore it, it'll work. Any other sort of general questions like that came out of those two chapters that you want to ask? Something that stumped you, confused you, or whatever? Did people have relatively good success with those two chapters? Yeah? Okay, great. That's fantastic. Let me see. I have to think at an angle. I can't read it myself. Can you pull it out a little bit? Yeah? Okay. So, yeah, one thing that you notice, and it's going to be a source of annoyance or a source of challenge, and this is not a characteristic of Rails, it's a characteristic of software engineering, is that you're using a whole bunch of different languages. There's no more like everything is one language. I mean, you have Ruby, you have Rails, which is kind of a language. You have testing frameworks like Minitest or RSpec, that is kind of its own language. You have HTML, you have YAML, YAML, you have JSON, you have JavaScript, you have, it goes on and on. The world is not yet, and I probably think it'll never get to the point where you can use one language to develop your whole system. So pick your battles. You can't become a total expert in all of them. In some cases, you should just treat something like, I'll just take the vanilla side. I'm not going to become a total expert in JavaScript. I'm not going to become a total expert in, what's another one that's kind of hard to become a total expert in? Well, anyway, there's other sub-languages. I won't, CSS is a big, you have to become an expert in CSS. That can't avoid that. And I'm going to cover all those things, although rapidly. But anyway, that's a phenomenon. You have to get used to them. So there's a lot of processors and pre-processors and post-processors that all go together. So when you do these rake commands or these deploys to Heroku, that long sequence is all those different compilers and converters coming into play. So let me just instead of I'm going to talk about NoSQL databases in a second, but let me just crank up my my terminal here and illustrate a few things which might, I'm sure you've seen it, but I'm going to give you a tour of it. So I start by saying Rails new delete me. It's what I call files that I remember to delete later. Okay, this command says it's running the Rails command line utility, and it's saying create a new Rails application. That always creates a new directory where you're at. So don't create the directory do Rails new because they're going to have an extra level of interaction. But some of you did that. It's a very common thing to do. So I do Rails new, and it says, oh, okay, this is interesting. So I'm going to see what Ruby version I have. 2.1.2, so I can just, this is now the RBNs that I talked about. 1.1.2, version 1.1.2. Okay, don't worry about that. If you don't have RBN, the reason RBN exists and you don't need it, as does RVM has the same purpose, is that, again, because the world moves so fast, people sometimes have separate environments on their computers to represent each version of Ruby or Rails, and RBN stands for Ruby environment, lets you change it, but don't worry about that. So hopefully now this will work. Okay. 2.1.2, that's where I'm at. Am I not? Oh, it went to 2.1.5. Oh gosh, I should have tried this before. Okay, can I say RBN version 2.0.0 dash? No, they don't. Let me just do. Oh, so I don't want that. I want current local RBN local 2.1. 2.1. Okay. So now I change the local version to that. If I do Ruby version, I should see that. And now if I'm lucky, I should be able to say Rails new me. Yay. Okay, and whenever you give Rails commands, it gives kind of a trace of everything it did for you. And this is where the convention over configuration thing becomes very clearly visible, because it's making a lot of decisions about what your directory structure should look like for you. And in fact, every Rails program, if you look at the directory structure, it looks basically exactly the same. Okay? So it complained again because I don't think that matters for now, so I'm going to ignore it. And now I'm going to go into my editor. And,
Wait, how did you do that command?
Which one?
Subble,
yeah. First I have to go into delete me. And then subble dot means enter the editor at this directory. Okay?
What's your other versions too? What's that P and then the number after?
Okay, that's a patch number.
Okay.
So version numbers go A.B.C dash and then random stuff. Normally I would, if you guys weren't all waiting for me, I would go through and clean it up a little, but I'm just using those versions. It's the same thing. Keep on asking questions when I do something that that looks interesting but confusing.
Should we do this with you?
Huh?
Should we do this?
You're welcome to. You're very welcome to. Okay, so this is all the stuff that was created by that one command. And you saw this when you did the work, okay? So let me just give you a tour of this, just to orient you a little bit. Tell me if it's too small, okay? I can't enlarge this part. The most important directory in your Rails directory is the app directory, although these are important too. And the app directory kind of contains your application logic, okay? And I'm going to start with models, which is, in a way, the most important of the most important. That's going to contain, these are all going to be Ruby files in here, and they're containing the Ruby files for the models. And we're going to cover the models more in the next couple of lectures. But basically, the models are the bit of Ruby code that acts like the intermediary between your relational database and your code. So that's the ORM, okay? Right now, there's nothing in there because I have created no models. There's this thing called concerns, which is also empty, but ignore that. The second most important thing is controllers. Controllers in the MVC world, okay, are the traffic cops between what the user does and what the server displays. So they kind of like coordinate things. They're kind of in the middle. They're kind of the conductor. And we'll go into that a lot more. And you'll see a bunch of files in here. What you always get for free is the application controller, because there is actually a hierarchy of controllers, and the application controller is the one that's always involved in all kinds of operations, and then they're specialized below it. This will all become clear as we go. And you see there's almost nothing in this file. The next most important are the views. And the views are basically HTML annotated somewhat, that's going to correspond to the HTML pages that are returned by the server. Remember, all the server does in its life is receives a URL with a HTTP GET, parses the URL, figures out what code should run, generates a bunch of HTML to return, and goes and returns it back. The HTML to return is living in the views directory. Okay? And we'll ignore the rest for now. The next important thing is config. Config is what it sounds like. There's a whole lot of configuration files here. The most important one of these is routes.rb. I'm not going to ask you to read this, but basically this is where essentially the code that explains how to parse a URL lives. Here's where you say it's /user/number. Here's where you say it's /form/edit. And here's where you point to what code to run if you do that. That's the routes file. You're going to use that a lot. The other one you're going to use a lot is the database.yml. This is the file, it's a configuration file that tells Rails how to connect your server with the relational database. Rails can run in different modes: development mode, test mode, production mode, and whatever other mode you want to invent. But generally it's those three. Okay? It is set up to allow you to have a different physical database in each mode. So you can have a development mode database, which got random data. You can have a test mode database, which has test data, which gets reset every time you run tests. You can have a production mode database, which actually has the real user's real information in it. And basically this thing, although they're using some crazy notation here, has a section for development, test, and production, which indicates that for test, this particular configuration is using a database system called SQLite, and the file name called db/test. In production, this, which is not realistic, is using, so you would edit this, a file called in the DB directory called production.sqlite3, and in development, that. Okay, so this is where you configure the physical database, because if you remember, you've got your Rails, you got your Rails application. You have the Rails application, and you have your database. And the lowest, in a way, the lowest level here is active record, which is the interface to the database. So in different modes, you can connect to different database over here. Let's see, I think that is, that's about it that's important. Let's go to the databases. The database directory contains a subdirectory that's not even created yet called a migration subdirectory. You all saw that. A migration, okay, here's the story about migrations. Here's the way to think about it. As you develop an app, you will discover as you add functionality, you have to modify the database. So add a column, rename a column, add a whole table, or whatever. If you have data in your database that you want to keep, you don't want to necessarily destroy the database and build it again from scratch, although sometimes you do. So that's where migrations came from. Migrations said, instead of just going into the SQL command prompt and changing the database, I'm going to write a set of steps called migrations that say, given the way the database is now, what change do I have to make to it to get to the next state? Migrations are files that get executed when you do the rake db:/migrate command, which you've all done. Often when something is not working, you forgot to do the rake db:/migrate command, so that's a good thing to plant in your head. Because you might have updated the database code, updated the models and so on, but never actually modified the underlying database to reflect it. Okay? So that's in that directory. Seeds is where you can put seed data. Seed data would be data that you want to be automatically put into your database as a result of just configuring your app. So it's kind of like built in there. Any questions so far? Everybody good? Okay. Going on, I think we're basically done. The rest is all less important. Yeah, the rest is all less important. Okay, so that's the quick tour of this. And I think I'll stop there with that part of it. So let me just hide this, hide this. Okay, that was the quick tour of the Rails app. Okay. Let's talk a little bit about NoSQL. Who wants to talk about what they found about NoSQL, what they found interesting, what they learned, what they didn't know before? Go.
I think it's pretty cool in the way that, like, I don't know, it's more elastic than SQL.
Yep.
And is used for like bigger data sets, which is useful. Well, right now, and going to be useful in the future.
Do you think? Did you say you think it's useful for bigger data sets than a SQL database would be?
Yeah.
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 Anybody have a comment about that, one way or the other? Agree? Disagree?
Well, actually,
Yeah.
there's a lot of people saying you can do almost the same as in NoSQL. You just have to be good at it.
Wait, you say that more, give me the complete statement.
So online, if you search SQL
Yeah.
versus NoSQL,
Yeah.
there's a lot of people who support just using SQL, saying that you can basically do exactly the same thing what NoSQL does.
Okay,
But,
they say that, what do you think?
well, I think
What's your conclusion?
Well, SQL just provides a kind of a robust framework,
Yep.
so it's less corruptible. So, but all the operations that you can do in NoSQL would cost more CPU time.
Not all,
Or
actually.
you have to
Yeah.
even
Yeah.
think about how to structure it so you encompass all the possible entries.
You have to think about how to structure it in NoSQL?
In SQL.
In SQL, yep, yep.
To avoid
Yeah.
mistakes.
Yeah, what my impression was like it's easier to like scale out NoSQL.
Yep.
But like SQL can't like scale up to that level. It's just like you have to really know what you're doing because I think like Facebook and even Google use like some SQL stuff for their stuff. They just like do very clever things with it, which
Yep.
you might not think to do.
How about you guys?
So one of the interesting things that I found is that for people who are doing ad hoc queries, SQL is apparently a lot easier to do, which I found surprising. But
did you understand? Or you ever thought about why that might be, or any insight
just
on that?
because I don't know, I just don't know. I wonder. I wasn't really sure why, but
Okay.
I thought that was interesting.
Yep. Yep. Anybody else have any comments about it? Yes.
Well, the way I understand it, with more flexibility comes like more power, and with more power comes much more details. And the way I understand is NoSQL has a lot of details to it that we need to specify as we're writing a query. Well, you know, a preface to all of this, I don't know how to write any SQL queries. I haven't done it before, but the way I understand it is most people who are using some sort of SQL-based databases in their own work, who are not software engineers or who don't know how to program, use it and take advantage of it because SQL is very much backed by the industry right now. There are lots of very well-established programs and services who do that stuff for you, and you don't have to know anything to be able to be productive. And if NoSQL, if there's a migration in the next 5 to 10 years where the industry shifts from SQL to NoSQL, then either the services are going to have to get better, or the people who are writing the queries have to learn how to do it. So that's a lot of brain damage there, but you know, I don't know how that is going to pan out, of course.
Right. Who can say from this table what is the essential thing that's different, the fundamental core detail that's different in NoSQL versus SQL? Yes?
Isn't it like you don't have to have structured data and you don't have to have like a scheme?
That's it. You don't have to decide a schema ahead of time. Right. Doesn't mean you don't have to design. You don't have to think about it, but you don't have to declare a schema ahead of time. And as a consequence to that, it means you don't have to have migrations. You don't have to change the schema. It just sort of morphs to fit. The essential thing about a NoSQL database is that there are not tables with columns. They are just, well, they have different terminology. They're just collections of documents, they call them, and every document can have a different set of properties. Now that allows for a lot of flexibility. It also allows for chaos, right? Yeah.
Oh, I was like, don't you also in NoSQL? I didn't quite get to this enough. Have to like say how you want to get your data, because like in SQL you just like get me this, and like it optimizes your query and gets it in some magic way. But in NoSQL you have to say like get it this way or something.
You have to say a little bit more. I think it's true. I mean, I think it does have to do with what somebody said, which is NoSQL is much newer. SQL has been around since the 70s, and so all the database systems that exist have been so heavily optimized, and they're backed by humongous companies like Oracle and Microsoft, and so it's a different scale thing. You know, if you find the premises, I mean, one example I saw in a real world case was this company had I think it was kind of like a social network, and for any particular user profile, there were like 100 different characteristics that you may or may not have. You know, what are your favorite books, your favorite movies, your favorite this, and each one was a complicated and distinct data structure. And so the question was, how do I do that in a relational database, since every user may have one of 100 complicated things, but none of them have more than 2 or 3. And then you could either end up with a very convoluted series of joins, or you can allow that heterogeneity in the structure of every user profile to be captured by the fact that NoSQL allows individual schema for every record, essentially. One last thing, which is why are people saying that maybe you don't need NoSQL? Well, one of the reasons is that certain databases have morphed, like Postgres particularly, to allow columns to have values that are not integer, string, or date, but are actually JSON. So complicated structures that are all different. So Postgres has kind of like evolved to be a little bit like a hybrid between the two. And that's the natural thing for them to do, and I'm sure Oracle and everybody else is doing something like it. It's a natural thing for them to do because they don't want to force their users to wonder whether they have the right database. They want to say, we'll solve it all. Okay? So there is a question as to whether NoSQL is kind of a temporary aberration which will eventually get sucked up into the conventional relational databases or not. But there's other things other than NoSQL, right? There's all, when you talk about big data, I mean, you have column-oriented databases, you have stream-oriented databases, you have all kinds of different databases. But NoSQL is one that comes up a lot in our world of developing web servers. Now, my personal experience is that it's kind of like what I was saying before about learning too many languages. Is everything I need to do, I know how to do with relational databases, and I just as well not bother until I have a super compelling reason learning a whole other database. But if you're fascinated by NoSQL and you want to make the back end of your product use MongoDB, I have no problem with that. It'd be an interesting learning experience if you feel like something about your app makes it kind of more justified. I'll be able to give you a little bit less help because I don't know as much about MongoDB, but that would be a legitimate thing to try to do. But really, certainly for our purposes in this class and for like really the huge mainstream of database-backed web services, relational database works fine. When you hear that companies like LinkedIn and Facebook and Twitter all have come up with hybrid databases or use a combination of relational database and NoSQL, or even have invented their own new kinds of databases, all which has happened, is because they confront a level of engineering challenge that far exceeds 99.9% of the apps out there. And so they are in a whole different world. When you have to support 1 billion users and you have 100 million online at once, or whatever the number is, 100,000, you're talking about a whole different situation, and then the database is the least of your issues when it comes to performance. Okay, but it's an important thing to know about. So now you have that in your tool set, something to consider. Okay. All right. This is very important. So imagine that I put up, as you did, I forget exactly what how far the homework went, but you put up a web page. The web page has links on it. You display it. The user clicks on a link, and another web page is displayed. And let's examine how that happens. So one thing that's true for any of these systems, not just Rails, but any of them, and it's a useful thing to think about in the context of the whole new generation of technology, which I'm not going to talk about, which are called single-page applications, SPAs, where the whole user interface is actually implemented in the browser. Set that aside. There is an underlying principle of all these systems, which is that when the user just sees a web page on their screen, it is the result of combining some number of records out of a database, whatever kind of database, with one or more templates, which are skeletons of web pages. And if you grab the data, let's say if you imagine a display of a user profile, something somewhere has grabbed data out of a database with information about the user. Something else has grabbed information about the general layout of the web page, and something has combined them together into a fully packaged web page that has both the results of the database as well as the HTML. So, for example, in my little app here, it's a weird app, so I don't want to, let me not talk about it. But in the apps you build, there's a database. Something does a query in the database, produces some records. There's a template, which we call a view. Something combines the two, and that gets displayed. That's the process. That's always the process. Okay? So let's think through for a second, and I'm going to ask one of you to narrate it as if it was a story. Tell me everything that happens from the moment at which not everything, but at a high level, when I click on a link, and I display, for example, the link is a name of a user. I click on the link, and I see the profile page for that user. Give a little, who's willing to be daring and give a little anecdote that says when you click on the link, that's a URL that sends a GET to the server for that new URL, and then what happens? Anybody? Yes?
I know the first thing that would happen was it goes to the routes to find out what the URL actually means.
Yeah, goes to the routes to find out what the URL actually means, yes. Go on.
And then from that URL it would run the specified code. I don't remember in what file.
No, don't worry about it. I'm talking conceptual now.
Okay, so it would run that code to generate the web page.
But in between that, first, there's a bit of code that just goes to the database and gets information about that user. Their name, their photo, all that stuff. As data.
Right.
Okay, and then what happens?
So once it has that data, it manipulates that data however in the code,
Mhm.
and then it renders some kind of HTML template or whatever just
Right.
to display all that data on the page.
Exactly, exactly. Let's take a quick look at what such an HTML template looks like. I'm sure I have something lying around in my directory that we can look at. These are all form demo maybe. That's a good one. Yeah, that looks like a good one. So we look inside this app, which I wrote last year, or actually I'm going to use it in this class for illustrating some stuff. And we look now inside the app directory, inside the views directory. We see 1, 2, 3, 4, 5 folders. We look inside of one of them, items, and we see a file called index.html.erb. This is what a view looks like. Let me give you a tour. Why is this thing doing this? I've got to stop it. It annoys me. Okay, can you read that? So this, first of all, looks a little bit like HTML. As you can tell, it has an H1 up there. It has a div here. I know we haven't covered HTML a lot, but you have an idea. It's all a lot of angle brackets. And then it's got a lot of these little angle percent equals things. Okay? Those angle percent, as you know from the homework, those angle percent equal things means that what happens between these two angle brackets is not HTML, it's actually Ruby code. And that Ruby code is executed somewhere else. It generates a bunch of text, and that text gets inserted here instead of the angle bracket equal thing. So it's just like a cut and paste thing. Okay? It's called a, yes?
What is the significance when you just have percent without equals?
Yeah, it's very important and a super easy mistake to make. If you have percent without equals, it runs the Ruby code, but does not stick any text into the file. It just runs it for its side effects. If you leave off the equal, you're going to have very mysterious behavior because suddenly nothing seems to be happening. Because it'll run the code, this link to is just a function or method. It's going to run this method with these parameters, which is going to always produce some text. And that text then is cut and paste into this spot, if you have the equal sign. If you don't have the equal sign, the text is just thrown out. Okay? Very important, very easy mistake to make. Okay? All right. So that's what a template looks like. So there's the act of taking that template and of combining it with the database, the data out of some data, wherever it's coming from, which then produces HTML, and that gets returned back to the browser. Puzzled? Anybody puzzled? Everybody good? Okay. So that's what one of those things looks like. So let's examine that same process through the action of through this diagram. So I click on that link. That, like any link in a browser, does a get to the server with that URL. The URL is parsed by the subsystem called the router, and it figures out what controller knows about that route. And let me show you in a simple case. What is the example used here? Is there an example used here? No. In a simple case, let's go find a pen that works. Is that one that works? I don't know. Nope. This one? Okay, a little bit. So, if my URL looks like this, demo.com. So I'm going to talk about URL design a lot in a soon lecture. Form 1. Then in the routes you will find code that describes this pattern. First off, routes assumes this has been stripped off. So the pattern will look something like the letter /FORM/ followed by :number, let's say. That's a pattern, right? And if that URL matches that pattern, then in the routes file it will say talk to controller form. So it's the form controller. And in there you will find a class with a set of methods, which we call actions in this case. And this router will further say that in this particular configuration, I can also know that the action is :show. And in particular, the parameter to :show is that number. So this is a declaration of how to interpret this URL. Remember, interpreting the URL is the first step. So that information gets sent to the controller. The right action is found. That code is run. And in that code, you almost always will see a line that says, grab information out of the database. You know, find form for user 3 or something like that. So 3, find user 3. And the database, with the intermediary of the model, will return that data, those records, one or more records. And then, furthermore, the controller will say, okay, I got the data. Now, what template goes with this? It'll select the right template. The template is partially executable, like we just saw, because it's got that angle bracket stuff in it. It'll execute that. It'll get populated. And then the controller at the end sends that information back out to the caller. Okay? So, that's why this thing is drawn this way. The controller gets given a user gesture, defines application behavior, maps user actions to model updates, because there may be an update, selects the view for the response, and uses, I don't know what this is, one for each functionality. The model encapsulates the application state, almost always by virtue of a database. And so the model is the connection between your object relational mapper and the actual data. Responsive state queries, you know, what is the first name of user 4? Response to updates, please change the password from A to B. And sometimes this is actually interesting, this is actually, leave it alone. I won't point out the mistake, then it won't bother you. And then basically returns that data over here, at which point the controller says, okay, I've got the data, I've got the view, put it together. So let's take a look at what that looks like in code. So I'm going to go now to a controller. We're looking at items, so I'm going to go to the corresponding items controller. Here's what it looks like. You notice it's, make it a little bigger maybe. Okay, you notice that it has one class in it called the items controller, subclass of application controller, and basically it's got a whole bunch of methods. And one of them is called the show method. The show method is the one that's used when I'm trying to show a single item, in this case. Okay? That show method is called, and the first thing it does is it looks in this automatically created hash called params, and params is where the router sticks these things, these parameters that are part of the URL. So if I had done item/3, for example, then params bracket ID would be the index into this hash, and params bracket ID would be 3. And so we'll do a find on the item model. This would return one record, which would be that particular item as data. And now, it doesn't do what I said. Now you get into what people say is the magic or the annoyance of Rails. So the story I just told you is the story in its full detail. It turns out that because that story is so common, that there's several places that I made it sound like there's 3 or 4 steps where you only code 1 step. And that's magic, but could be confusing. It turns out that if the required view is called show in a subdirectory called items, in a subdirectory called views, then it automatically knows which one it wants. So if you look at the views, you see there was a directory called views where all the views live. There's a subdirectory called items, which is all the views corresponding to the items controller. And then there's a subdirectory called show, a file called show, which is the file that would be displayed in the case of that particular action in that controller. So there's a lot of defaulting, convention over configuration going on. The defaulting is that if the view you need, and this is what you try to do all the time, if the view you need is named view directory, controller name subdirectory, action file name, .html.erb, then you don't have to say anything. The controller knows that that's the one you want, and it goes to find this one. Let's study this one. Remembering that, how do I do 2 columns of this little thing? Oh, I know. There's a better way to do it. That's the way I know. There's the view, and here's the controller. We're talking about these 3 lines. The first, so the biggest part, so now we're actually, I switched example. I'm actually doing items /4, okay? So the router parses this, says, it's the items controller, and it's the show action, finds the items controller, finds the show action, executes this 1 line of Ruby, which sets up in the instance variable called item the result of that find. So add item now contains 1 record. Now it says, okay, I'm at the end of this thing, so I better be able to find a view by the right name in the right directory, and it finds this, and it starts executing all the angle bracket equals, and there it is, at item.title. It's just pulling it out of that instance variable. At item.description, at item.owner. That's how it's populating the view with the information out of the database. It's critical. If you're doing your homework, you ever got an error message that says, can't find view, blah, 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 it has to do with this naming. If you don't say anything more, if you just end the item action, the action like this, and there isn't a view by the right name, it's just going to give you an error message. It won't know what to do. This is really important. I mean, it's not when I mean it's foundational. This is going to be your life. So if you have any questions right now, please throw them out. Yes.
Yeah. Also, if you're making that initial I know in the homework we had to make the product I'm going to call it class. I don't know if it was actually a class.
Yep.
The controller. If you have a typo inside one of the parameters, you're not going to realize that at first. You probably have a typo if you can't find a certain parameter.
Yeah, typos are killers. Yeah. And there is a tendency, there's a temptation, when you see an error message, which usually has a big stack dump and it's a big mess, to immediately just go to your code and try to, stare it down and figure out what's wrong. Force yourself to read the error message carefully. Find the line that mentions the line number in the file name. And very often it's there. But people very commonly get so excited that they immediately go look at the code because they think they can just just like by pure mental energy, figure it out. Take a breath, go read the error message, because often the answer you need is right there. Okay? Yes?
I had this problem when I was doing chapter 6,
Yeah.
and rake test really helped.
What is rake test?
Rake test.
What did it do?
Well, I'm not entirely.
That's okay.
The way it works is it sets up a series of test commands and it runs your program through it.
Yeah.
And it sees, I think it tries to cover all bases of
Yeah.
some sort.
Yeah.
And I don't know, it's a lot of magic for me. But
Yeah.
I had one problem, like when I was setting up the shopping list
Yeah.
item. You're supposed to do like a symbol title,
Yeah.
the title of the item. My colon and the title were separated. So on 7 different occasions of my, the depot folder,
Yeah.
there was this title variable, but it wasn't symbol. So
Right.
I read the rake test errors. There were 7 errors.
Yeah.
Once I realized that all 7 errors were pointing to one line in one file.
Yeah.
But there were 7 errors because it tried it 7 different times.
Yeah.
I realized that all I had to do was just combine the colon and the title, and it worked.
Got it. That's pretty good. Anybody else remember a point at which they were totally stuck, and what turned out to be the problem? Okay, so everybody else completed the homework successfully? Good. Excellent. You're the only one. They're lying. Guarantee it. Okay. Let's see what I wrote here. Yeah, this is just this is a quote from a previous outside reviewer. My focus on the schema all along is because the schema of the database, if you haven't figured out the schema, you haven't figured out the functionality. So that's really important. In fact, tomorrow you'll see in the homeworks to come up with the first round of the schema. Okay, we talked about that. All right, good. Let's go on. I talked about migrations, but let's no, because I'm going to go into the mechanics in a second. So just see how my sequencing works here. Okay. Okay, that's good. So I talked about migrations. So migrations are every time you modified the database, instead of actually going into SQL and modifying the database, you create a migration file. You all saw this Rails generate command. What you might not have realized, which I'm going to show you, is that there are a lot of different generators. Oh, great. Messed up system. Okay, bundle. So there's a bunch of generators, and the generators all are pieces of Ruby code, although you don't have to worry about that, which go through and generate files, generate pieces of code for you, or modify existing files. So there's one generator to generate a migration, and that generator basically will create a little file in the migration subdirectory to represent the changes you want to make to the database. Then you have to go into that file and edit it yourself to indicate the change. Okay? So typical migrations are things like add a column, delete a column, change the data type of a column, rename a column, things like that. Or sometimes add it in the table. When you run the migration, there always is a file which you shouldn't run per se, but it gets created automatically for you in the database directory called schema.rb. This is not a file you create. This is a file that's created for you by Rails, and it reflects all the way it thinks the schema should look right now. Okay? So this particular database has 1, 2, 3, 4, 5 record data tables, and with these columns. If we look at the migration subdirectory in this app, we see that there's a number here, and that number corresponds to essentially the order in which you want the migrations to run. And you see that I'm doing something that I like to do early in a project, and that is, okay, let me just draw a picture here again. So if my database has two tables, let's say course and student, then when I first start, there will be two migrations. And I'm just going to pretend that they're called. Number one, create course database. I just make up those names myself, .rb. And number two, create student database.rb. And if I do rate db migrate now, it's going to execute this one. And if you read the code, it leads to creation of that table. And then it's going to execute this one. If you read the code, it will lead to the creation of that table. If I do rate db, is that a hand? No. If I do rate db migrate again right now, it'll do nothing, because it knows that it's already at version 2. If now I want to add an additional field to course, let's say I'm going to add the enrollment, the natural and default thing to do is to add a third migration, which is going to be about, remember the name of the migration is just comment. The code in the file is what matters. Add enrollment to course.rb. And if I do rate db migrate now, it says I'm at 2, I need to be at 3, I'm going to run this one, it's going to add the column. Okay? The effect of this is that you never have to delete the whole database just to add one column. And deleting the whole database might be bad because it may have data in there you want. That's the origin of the way this works. And a mature project can have dozens or more of these, and it'll be, in reality, already up to the last one, and all you're doing is adding more. Now, it turns out the thing that's kind of problematic about this is that now, essentially, the description of your schema is spread along a whole bunch of different files. You almost have to read each one to figure out what your schema is. That's why that schema.rb file is created. Now, another work practice, which I do early in a project always, is I will have only one migration for every table. And if I wanted to add this enrollment, I would edit the create courses database and add it there, and then delete the database and rerun it. The drawback is that I've just killed all the data I might have in there. The advantage is that they don't have a mess of migrations. So that's what I do. I find it handy. You may consider doing it, but they're certainly not considered to be the only way. It's just a way to do it. That's why when you look at my directory of migrations here, you see that there's exactly one per table. Create item, create categories, and so on and so forth. And so here, for example, late in the game I decided I need a sessions table. So I added it as the last migration, but it's still creating a table. All of my migrations create a table. And there's different commands, which I'll show you as we go along, that run migrate from where you are till the end versus resetting everything and starting over. Okay? Okay, so that's the migration. All right. Okay, let us go into the old delete me app that I created. That's not it. Kill this. So I can illustrate exactly what I'm doing in code, in addition to talking about it. And we're going to see how good I am remembering these commands that I never do. Okay, here's my, oh, it's still installing break, are you kidding me? Okay, it's almost done. Okay, cd/mydev/delete me. Okay, make it smaller. Close this for now. So first I want to say Rails generate, see if this works now, is it still going to give me a problem? Okay, good. So these are all the different things that can be generated. Okay? And if you go one level deeper and say Rails generate, I think you just put a G, model by itself, without any parameters, you get documentation for Rails generate model. Actually, let me just kill this so you can see it properly. Okay, so it shows you a lot of information. Okay, all the switches, blah blah blah. Does a lot of stuff. So I'm going to do a Rails generate model. I'm going to call it item, and I'm going to give it two parameters: name, string, school, string. And look, let's see what it did. And you did this in homework, so I'm just reviewing, but I think it's handy because I can make a lot of comments about it as I go. What did it do? It created a file called the migration that we talked about. It created a file, which is the model file for item. It created a unit test. It created two tests, that's what you're talking about. And it even created a text fixture. So now let's take a look at the code that it created. Okay. Oh, why is it that? So we're going to look first at the migration. There it is, the one file. It created this for me just because I did the Rails generate model with those two columns. And it created the migration that creates that table called items with two columns. Yes?
What's the difference between using generate model versus generate scaffold?
Okay, very good question. Generate scaffold creates fake, or not fake, not kind of default views for you. Generate model didn't do any of that. Scaffold is a good way to learn, but you need to understand, and you will understand exactly what it does. Eventually you won't need it anymore. But it will have done all this as well. So now if I go back here and I do rake, first let me do an ls of DB, of the DB directory, and you see here that all it has in it is the migrate subdirectory and the seeds file. Okay? Now I'm going to do rake DB migrate. Rake is the, those of you who know make from the C world, it's just an application, a utility to help you automate common programmers' tasks. That's all it is. So what you got to learn about rake is what are the permissible commands over here. And I actually have a handy dandy cheat sheet for that. Do I have the cheat sheets even listed here? Crib sheet, sorry. I have a long list of really wonderful crib sheets, and one of them is called the rake task crib sheet. And if you look here, you'll see all the ones that I think are the most common. And there's a lot of cool crib sheets there. Okay? So now, if I go back and look again, DB, now look what happened. I have migrate that I did before. I now have schema.rb, which I did not have before. And I now have development.sqlite 3. This is the database file. This is what's going to contain the records. This is the schema, which I told you gets generated automatically. Okay? So in fact, if I look inside the schema, we'll see exactly the same thing, except this is static, this reflects current reality. If I look inside, what's the other thing I want to show you? Oh yeah, the database, the config file for database.yml, you'll see that because I'm in the developer mode, the file name is development.sqlite 3. That's where it got that name from. Okay? Now, no, not that. Yeah. Over here? No. Over here, I say. Seems it gets not getting bigger. Okay, here we go. I'm going now into IRB. No, and I'm going to. That's IRB. You know that. But if you're in a Rails program, you can type Rails console. Also abbreviated Rails C. That puts you into IRB after having loaded all the Rails stuff. Okay? So, I know that I have a table called items and has a name and a school. So I can do a few things here. And now I'm going to be talking directly to active record. Remembering, okay, I'm going to first show you items.create name : pedo school colon Brandeis. Okay, what are they wrong? Oh, it's not plural, it's singular. All right, so if you can see that, oops, do another one. Okay, it's kind of hard to parse, so I'm going to walk you through it. First thing you see up there in purple is the fact that that's a transaction to the database. The next line, insert into, is SQL. So active record is actually writing the SQL for you. And the next line, that's the parameter. And then finally, this arrow says the value of this operation is basically that record. Since I created 2, it's ID 2. It's got the same name in school, created that, and so on. So I just created the record in the database. Okay? So if I say item.all, I see gibberish, but if you look at it closely, you see that we have an array containing one item and another item. Okay? So this database already has 2 records in it. If I do item.all.count, it says I have 2 records. Yes?
So if there is something in the seed file, then it also have that for everything that you've added in.
If I did not ask the seed file to be invoked in this case, but normally you would, then those would have been added. So then the idea is whenever you do a build, you automatically get a few records to play with. Notice that if you look closely that the class of this record is item, which is the thing we're talking about, and it's got values for all the different things. So what you're seeing there is active record in action. All right. So if we look now, at DB, we see now that this development.SQLite 3 is no longer empty. Now, of course, it's going to be a binary file, so it won't make much sense, but if I look inside it, you can sort of see that this contains the records. Okay, this is the schema over here, and here finally is the record itself. Okay, so this is obviously ugly. It's not meant to be done this way, but I'm just showing you that doing those commands in the Rails console has caused records to be created in this database. Okay? Let me go back to my storyline here. Okay. So active record is the subsystem that allows me to create these models. And it's the one that contains all these methods like create and delete and destroy and all that stuff. And that's a whole study in and of itself. Yeah, that's always confusing, but when you say Rails generate model, okay, the table in the database is plural. So if you say item, the table will be called items. But the class created is singular, item. And it is clever about words that don't have obvious plurals. And you can have fun with that. Like, what if it's goose? It'll know that it's geese, and so on and so forth. You can play and see where it falls down. Now, this is another interesting thing I want to show you. You learned all about class design. And you learned that if I can say, go here. If I can say the items, equals item.all, then I should be able to say the items 0 to get the first record, right? And I should be able to say pedo equals the items sub 0, right? Because the items has 2 items in it. And I should be able to say pedo.class, and it's an item, right? But I can say pedo.school, and it's Brandeis. So it looks like there's a method or an instance variable called school on that class items, right? Everybody with me? If we go look at the code, at the model called items, that's all that's in there. That's all that there's in there. Okay? one of the things that Active Record does is when you connect it to the underlying database, it inspects that database and automatically creates methods here for you. And it's this is one way to overcome the age-old problems between having an ORM, the problem caused by having an ORM, which is keeping the names matching. If I have an ORM, I want to have the names of the columns available to Ruby programmers, but the names of the columns also want to be available as columns in the database. So the problem with ORMs always, or the thing that's annoying about ORMs, is if I change the column from school to university, I'd have to change both the Ruby side and the database side. So one solution to that problem is what Active Record does, which is instead of having you declare specifically in the source code, it talks to the database and asks, do you have a table called items? Or whatever they're called? Yeah, items? Yes, excellent. Tell me all the columns you have and what their data types are. And then it secretly behind the scenes creates those methods for you. Okay? That's why there's nothing in there. Now, there will be stuff in there as you go forward. There'll be validations, there'll be other code and so on. In fact, one of the key design challenges people always have is to decide where to put a method that does something. Like if I had a method that was supposed to return a string suitable for mailing to me by taking my name and my address and putting the carriage returns in and so on, and a zip code in the right position, I could make that a method on item, and I would take the name, take this, put stuff in. But you might argue, and you would argue, that it doesn't really belong in item because it's not really part of the job of the data. That's really a formatting thing. So you would put that formatting thing somewhere else. But that's a fairly obvious example. If you're thoughtful about your design, you will find yourself trying to figure out, and you will come ask or discuss with your friends, should I put this here or should I put it there? And in fact, one of the classic code smells in Rails is if your user model becomes what they call a God model. When people talk about a God model or a God object or a God class, they mean somehow all the functionality of this system is all living in this one class. And so the temptation is to, it's easiest to put it here, you put here. So the question of where to put it is an important one. Okay, now let me go on to see what else I want to touch on here. Just like I drew the picture before, when you're running on a test machine, like on your computer, your laptop or whatever, or whatever end, you basically have your laptop, and on it you have running a process that runs Ruby essentially. It's the Ruby interpreter, which is running your app, which also includes as a library Rails and whatever other gems you have. Now Rails wants to now connect to a database. There's different databases for different purposes. That's why Active Record is sort of the adapter for the two. The way, when you're using something called SQLite, which is a very good default to use, it turns out that SQLite itself gets built into your app and just stores its data on the file system. This development.SQLite 3 file. That's a totally test environment. That would never work for a product. The much more common thing is that you have a database driver here of some kind, which uses the network to connect to a database server. And typical examples of this are MySQL and Postgres. There's many others, but for our purposes, these are the most common ones. And you can actually run MySQL or Postgres on your laptop as a separate program. You have to launch it separately, you have to kill it separately, it's in its own prompt, you have to install it separately, totally a separate process, but your Rails app talks to it as if it was talking to another system, so that in the future when you deploy your app to the cloud, it can actually be a different computer altogether. Okay? It can be a different box in a different city and still talk to it over the network. Hence, there's a choice of databases, and sometimes, in fact not unusually, you will use SQLite for development because it's all on your computer, and Postgres when you deploy it. But you can also run Postgres on your computer and configure it so that it works in the same way. When we deploy to Heroku, you will see that Heroku insists on Postgres. Some people think that it means that they have to use Postgres on their laptop, but that's not true. You can easily run it with SQLite on your laptop and Postgres on Heroku. But that's one of the big jobs of Active Record and of the ORM, is creating this isolation so that all your code, 99% of it, can be very, very careless or unaware of what it happens to be connected to. And that's a really big deal. Because, well, take the example of deploying, sometimes a database system costs hundreds of thousands of dollars. You don't want to have it run on your laptop or all your employees' laptop. You give them a free open source thing to run on their laptop. When you deploy it to the cloud, you plug a different database in and everything still works. Your testing works, your quality works. That's another very big job that that the Active Record does. Okay, how are we doing? We're doing great, actually. We talked about migrations. You get just these Rails guides, by the way, are excellent sources. So they're just on the web. Just type, Google Rails guides views or Rails guides or migrations, and they have really good, succinct but tutorial formatted instructions. I look at migrations just to show you what they look like, and it's really excellent. Sometimes this is all you need. Very, very tight, very clear. All the data types that are available, here you go. In case you're wondering what's available, that's what's available. Now that's interesting because these data types appear in, we have 10 more minutes, yeah. Because these data types appear in your Ruby code, in the migration files or in the schema files, they don't pertain to a particular database. So what Rails has undertaken is to figure out what each of these data types might be implemented as or interpreted as on SQLite or on Postgres or on Oracle or on whatever. Again, you don't have to worry about that. So these, you're going to use these in your migrations, but you're going to get 99%, if not more, of the way done with integer, string, date, time, Boolean. The most common ones, maybe float. You're going to get a lot of like almost everything. Rails validations. So one job, is this one of my crib sheets? Let's see. Yeah, it's one of the crib sheets. One of the jobs the model can do is to validate. I can put in here something that says validates name, length. This is just, you got to follow the format, call it like that. Minimum 3. And I can even go further and say too short, silly case. Now let me make it. Name needs to be 3 or more characters. Okay? So let's parse. Yes, go ahead.
Did you mean to type too short or too short?
Oh, I meant too short. Thank you. Although it would have been always fun to see exactly how. Okay. So this is now. Yes?
So for like passwords, this is how they mandate that? Using something like
Yeah, exactly. I mean, these ones are sort of, in fact, it's probably here somewhere. But let's see what, so let's see what happens. So now I did this. I'm back in my Rails console. I'm going to try to do a create ed, and let's just see closely here whether it, maybe I have to exit and restart, or it's reload, I think. Ah, very good. Let's read the error message. Don't be scared by all that stuff. Go open it up and look at it. Okay, so first of all, it failed because the validator was unknown, too short validator. Why is that, I wonder? Let me look back at my crib sheet and see whether I can figure it out. Validates, content, length, that, too short, arrow, quote. Let's get rid of this to see whether this version, because I'm running on a funny version because of the problems I had demoing before, remember? Ah, now it didn't do, let's see now. Oh, okay.
Which is parentheses.
Yeah, close parentheses.
Oh, yeah, sorry, thank you. Okay. Okay, now it says unexpected close parenthesis. And that's pretty hilarious, isn't it? Let's see, item create, close parenthesis. Oh. Is the error in here? Anybody?
It looks like it has to be in brackets.
But this thing itself?
Actually has to be in brackets.
Oh. Length, curly, yeah.
No, what's invalidates has to be in brackets. Like what you're testing. According to the page.
Wait. What line number?
2.
This has to be in brackets?
Well, after that.
This?
No.
Here? I don't think so, but because the error message is something about parentheses. So let's see here. All right, that looks good. And then I go over here. I'm going to stop messing with this in about 30 seconds, but. Oh God, I'm sort of in a nested Neverland here. Okay, it was item, right? Ah, good. That's what I want to see. So it didn't, let me just illustrate. The way I know it worked the way I wanted it to. Oh, God. Okay. It's so confused right now. I'm going to show you another trick. A equals item dot create user colon A, which should fail, right?
Oh, name.
Oh, yeah, okay, name. Okay, so A is now equal to the result. It looks like it got it, but actually the fact that it said rollback transaction here is the clue that tells me that it told the database, forget about it. This is not a valid record. And you can go a little bit further on that path by going a.errors. Okay, because this is an important one, maybe I'll end with this. Active record will allow me to deal with records as if they're objects. You saw that, A equals and so on. However, they're not the same thing, okay? You can have an active record object in memory that never made it to the disk. Prime reason is it didn't validate. So if I try to say a.save here, for example, say really put it in the database, please, it's going to know. It's not going to do it. If now, when that happens, I can ask A, hey, what are your errors? And it says, oh, look at this. I have an error called too short, minimum is 3 characters. So I can even go, is it string, text? remember that. But there's another A dot error. A dot errors sub 0. The first one, nope. A dot errors is dot messages. Dot messages. Okay, it's still a hash because it's data. The message